Hello, everyone, and welcome to the next generation of energy brought to you by the folks at RoseWater Energy. I'm your host, Tyler Kern. Thanks so much for joining us for this episode of the show. Today, we're taking a look at a number of backup options like generators, solar panels, and things of that nature. We're going to be discussing the nuances of all of them and also some of the pluses, some of the negatives of those as well, and then talking about what the ideal backup for a home is. What does that look like, and how does that all shake out? And joining me today, once again, here on the podcast is Joe Piccirilli, the CEO of RoseWater Energy. Joe, welcome back to the show. Thanks for joining me once again.
It's always my pleasure to be on your show, Tyler, and I'm looking forward to a good discussion this afternoon.
I'm looking forward to it as well. This are always just such exciting conversations for me. And so let's start things off by discussing the differences between a generator, solar panels, and battery backups. And let's kick that off just by defining, what is a generator, and tell us how they work and what their shortcomings are and things of that nature.
Perfect. I mean, I want to have a little bit of preamble because it wouldn't be normal if I didn't talk a lot. A generator, which is what people generally use for power backup in their homes, and a generator is the same type of device that utilities use on a much larger scale to provide electricity to the entire country. A generator is a motor. It's putting out a continuous voltage that's matched to a demand, what your house is drawing. However, what it can't do is it cannot anticipate a load change. So if one of your air conditioners turns on, the generator will sag because the load goes up, the demand on the generator goes up, and the generator takes a bit to catch up. So that creates a sag. And then when the air conditioner turns off, the generator is still producing the amount of power as if the air conditioning is on, so that creates a spike. And there is no way for a generator to anticipate that load. So it can create power anomalies, sags and surges, through no fault of its own. It's just the nature of the beast. And it is those problems, the sags and surges, that can create issues for all the automation in a home. But what it's really good for is a generator will back up your house for as long as you have fuel. So for long-term power backup, it's a very, very good device.
Now, when we talk about generators, it's also common that generators are notorious for poor power quality. Is that right? So tell me a little bit about how that should be factored in when you're making decisions or thinking about the ideal backup and that sort of thing, just the poor power from a generator.
Actually, it's a great question because there are two problems. We discussed the sags and surges, and in many cases, people will underspec their generator. So when they underspec it, they end up with a generator that can barely power what you want in your house. And, people do it for budget reasons. People spec them that way because they don't think the client will spend the kind of money to get it right. There are all kinds of reasons for this to happen. But as you underpower the generator, you create greater sags and greater surges. And the only way to protect yourself against those things is to have a power conditioning device like a RoseWater unit that, regardless of input, can never pass a sag or a surge. So in many of our installations, the RoseWater is there to protect the house not only against sags and surges from the utility, but sags and surges from your generator. And it is amazing. There are lots of people who own generators who find that their equipment goes wonky when their generator is testing or when their generator turns on for a small power outage because of what we had just spoken about, the sags and surges that are innate in the device itself.
It's really fascinating to discuss, and I feel like I always learn a little bit more. But that's just really interesting about generators and the way it obviously can't anticipate what your need is at any particular time, and so AC kicks on, that surge generator doesn't expect it. There's a sag. Really, really interesting just to think about and to discuss.
I think it's important to note that 25 years ago or 30 years ago, sags and surges created by generators or created by utilities went virtually unnoticed. I mean, the biggest thing people noticed in their house, and you're probably too young to even remember this, your digital clocks blinked, your VCR blinked, and that was the effect of a power quality issue. Today, those same power quality issues, your lights won't work. Your home automation, your networking, all of that is at risk. So what has happened is that power quality, the effects of power quality have become much more consequential on people's lives. So that's why we're beginning to notice it more and more and more. Of course, other factors as well. The grid is aging, and people are building bigger and bigger homes. So I think it is important that people understand that it is the very nature of a generator and the utility itself to sag and surge.
Well, and I haven't checked the numbers, and so I can't say this for sure, but I'm willing to bet that after the February that we had here in Texas, that generator sales probably surged because more people were looking to buy generators and looking to have an option as a backup, because we experienced something here in Texas we hadn't really experienced before, and that was losing power due to cold weather and the ice and the storms and that sort of thing. And I'm willing to bet that a lot of people went out and bought generators that hadn't previously considered it and have never considered the positives and the negatives that generator can provide. So I think this is a really interesting educational element that a lot of people across the country, not just here in Texas, but a lot of people across the country need to know when it comes to what their power needs are and how a generator can and can't meet those needs.
Exactly right. And I would say being in the generator business for the last few months in Texas was a really good business. Because, as you know, I live in South Florida, and every time a hurricane hits, they ship generators down here by the trainload, because that's when everybody wants to buy them. And as you know, because you just lived through it, when you're without power for a few days or a week, and it's really cold or really hot, it's not that much fun. Not that much fun at all.
You are correct about that. It is. It was not the best few days of our lives here in Texas. That is for sure. So as we're discussing these options, let's move on and talk about solar, because I think of all of the various things that we're going to discuss today, all of the backup options and the things that exist, I think solar is probably the most misunderstood. And we've talked a lot about solar on the podcast for this reason, because I think there are a lot of misconceptions. But introduce us to solar, give us some of the positives and negatives, and really kind of round out the thinking as far as solar panels are concerned.
Perfect. And you're right. It is amongst the most misunderstood technologies that exist. Much of it, there's a lot of hype around solar. Oh, it's free energy forever. It's so it creates a lot of misinformation in the marketplace. And I'm an engineer by education, so I like to start out with the math. So if you were to think about it, and it is generally agreed that the sun puts 1 kilowatt of energy per square meter on the Earth. Now, that figure is sometimes exaggerated when people calculate, well, the sun puts out this much energy, therefore it must get to the Earth. Well, no, because we have an atmosphere, and we have clouds, and we have water vapor in the atmosphere. So most scientists agree that it is 1 kilowatt per square meter. Well, what does that mean? You have a 500-watt hairdryer. And I'm only sitting there to put it in perspective. So a kilowatt, 500 watts is half a kilowatt. So it is not a lot of power. And then when you take into account that a solar panel, a good one, is 20% efficient. So when you're at 20% efficient, you are putting 200 watts of power per square meter. So think of it as a little larger than a square yard. That's what you have as available power under ideal conditions. So the sun must be out, the atmosphere, it must be a cloudless day, and the angle to the sun must be perfect. So if your house uses 3 kilowatts, 5 kilowatts, a small, not a huge draw house, you're still talking about, if I do my math right, I think you're talking about 250 square yards to do 5 kilowatts. That's a lot of solar panels. And then, of course, what do you do? What do you do at night? What do you do when a cloud goes by? Cloud goes by, it could lose as much as 90% of its power output. And yes, it's a brief period of time, just long enough for all your breakers to trip. So, it does create problems because it is intermittent and because the amount of power available based on today's needs is not enough. People tell me all the time, oh, I'm going to put enough solar panels on my house to power it forever. And I'm going, well, that's okay if you live, at the North Pole and you have 18 hours of sun a day and you sleep the other 6, and your house is, a couple hundred square feet. That'll work. But in today's world, that's just not going to happen. It can't. And people are expecting a miracle. Oh no, solar panels will do this. Well, I would want to recheck my math, but the last I looked, the solar panels used in space stations, which are outrageously expensive, don't get to 40% efficiency. Yes. So we've got a long way to go before we can get to something that is even close to viable, and that doesn't solve the intermittency problem. And what people don't understand is you really can't beat the math. There's just no way around this. People keep telling you, they keep quoting numbers under absolutely ideal conditions that might exist for 1 minute a day. So the way solar should be viewed, it is like a hybrid automobile. Is there a way to make the use of electricity more efficient? Can I minimize my use by adding solar panels? Problem, of course, when you do that, the return on investment that is purported doesn't exist. That's just not there. But from an environmental standpoint, if you can sit down and say, I am mitigating the use of fossil fuels because I think they're going to run out, or you have CO2 issues or whatever, that makes perfect sense. As a standalone, not a chance. Not a chance. Now, the next step, and we were going to talk about it anyway, is, okay, what if I use batteries? And, you take your solar energy. If you have excess during the day, you charge your batteries during the night. You can power it, and also it makes up for the intermittency. If you begin to calculate how many batteries it would take to power your entire house for any length of time, you're going to have to build a separate building on your property for those batteries. It doesn't work. So now, good solar guys, we'll talk to you about value engineering. And value engineering is all around, tell me what your most critical loads are. The whole house is off the table. We're not doing that. And that's what the good ones will say. And they'll just go, okay, let's pick 8 or 10 circuits, 10 at the max, and go, all right, those are the things that in a catastrophic failure, I want those to run. And then you can use solar power with battery backup and you can get away with it. Beyond that, there's not a lot of use, and you still don't solve the problem of surge and sag, because the intermittency itself of solar creates surges and sags all the time. Batteries do not anticipate load. So, and then there's something called an inverter. And again, a highly misunderstood device. Batteries put out direct current, right? DC, your house runs on alternating current, AC. An inverter takes DC and makes AC. So now the question sits, is that inverter connected to a transfer switch so that it kicks in when necessary? Well, if that's the case, it does not power condition, because it is going to create surges and sags all by itself during the switch process. The ideal situation is that the batteries are always powering the inverter and the solar panels are charging the batteries at all times, so there is no switch. That's how RoseWater works. We have to use the grid or solar panels to continuously charge batteries, which continuously feed the inverters. So there is no such thing as a transfer time, and we can guarantee perfect power at all times. And I know that's a long-winded discussion about solar, but it is one of those things that people have to begin to realize, wait, let's do the math. And you notice that all of the people who tout it never start with this is how much energy is actually available. So that's my story.
You said that was a long-winded explanation, but I think it's a necessary explanation, right? Because as we started off the topic of solar, I said I think it's one of the most misunderstood technologies, and so I think it deserves that explanation, because if people don't understand the nuances, if people don't understand the truth about what this technology is capable of, then people dive headfirst into a technology that's not ready maybe for how they want to use it without having the full knowledge of it, and then they get soured on solar. And so later on down the road, when solar is a little bit more mature, maybe of an option, there are going to be a bunch of people who can and should take advantage of that that won't, because they have a bad taste in their mouth because they got bad information early on in the process. And so I think it's good and I think it's right to properly inform people about the capabilities, the advantages, and the drawbacks of solar so that people don't have a bad taste in their mouth about this emerging technology once maybe there are more options available within this market.
You are absolutely right. And that is really the shame of it all, because we have mismanaged people's expectations about what this technology is going to do. And we've soured a bunch of people on a technology that ultimately will be extremely useful to society in the future. And it is, remember, in the early days of solar, people were touting return on investment. The utility is going to buy the power, the solar power, and they're going to pay outrageous sums for it. And yes, in the beginning, that was absolutely true. Through some form of government program, the utilities were paying 2, 3, 4, 5, I've heard as high as 8 times retail for, so return on investment becomes very strong at that point because, 8 times retail, yeah. I mean, I know I think it's in the city of Ontario, they were paying 81 cents a kilowatt for anything generated by a solar panel. Retail for power in the city of Ontario was 10 cents. So from your electricity bill, the utility charged you 10, but they had to buy your solar power at 80. So yeah, there's huge return, but it's an unsustainable business model. You just can't keep doing that. So, people bought lots of solar then, and they actually never powered their house with it. That's the other big thing with solar people don't understand. If you use solar panels without batteries and you're selling back to grid and your power goes down, your solar panels don't work. They cannot power your house because you can't allow power to be put back on the grid when people are working on the grid, because you end up killing people. So you get a lot of disappointment in just the way it was presented. And to your point, it's very sad because ultimately it will be part of our electrical infrastructure. And it's going to find its niche. Even at current technology, it will find its niche. It'll find its place in the grid structure, just not as it's touted today.
I think that's absolutely correct, and I think that's very well put on your part. And so at this point, we've talked about generators, we've talked about solar panels, and also battery backup. But let's talk a little bit about power conditioners as well, because I know there are 2 types of power conditioners. We have transformers and double conversion inverter systems. Can you break down the difference between those two and kind of tell us, why the distinction there matters?
Absolutely. A transformer, which is just giant, big coil of wire, that can, on the output side, put out constant voltage. And within a certain range, the voltage on the input could vary. And due to the way coils and magnets work, it will keep a steady 120 volts, which is great. That is what conditioned power is. Regardless of input, output is at the desired voltage. What a coil or a transformer can't do is take big swings, because it's just not geared. It will saturate, and then it will begin to get a little weird. And it also cannot compensate for frequency. So if the utility drops the frequency, to 55 hertz, the transformer is going to put out 55 hertz. Whereas in a double conversion inverter, frequency and voltage are always perfect. And the way that works is all inputs in double conversion are converted to DC. That begins the conversion, first conversion. And then that DC input, which is brought down to a specific voltage. In the RoseWater case, our batteries work at 48 volts and our inverters take 48 volts DC in. So we take all AC and convert it to 48 volts DC. The batteries are always hooked up to the inverters. And it is through that double conversion process that we can guarantee the output of our device to be not only 120 volts at all times, regardless of voltage swing, but we can also guarantee that it is 60 cycles. So the other issue with a transformer is power's out, you're out. So there's no way to battery back up a transformer without buying an entirely different device. I've got my battery backup device hooked up my transformer, and people do it. People do it all the time, and it is a way to go. and most people concur, I am a believer that if you have an excellent double conversion inverter, you're going to produce the highest quality power at all times. Does that make sense? Is that clear?
Yeah, yeah. So someone listening to this might sit here and say, okay, Tyler and Joe, you guys have talked about generators and solar power and told me all the things that I should be aware of and that sort of thing. But what's the solution then? If I want to talk about having the best backup energy source for my home possible, how do I go about doing that now? Because I'm concerned about solar. I'm concerned about generators because of the issues we've raised. How would you recommend someone going about figuring out and finding what the best backup for them is?
Well, if you really start to look at it, because it is a great question and we're getting into the engineering of it, if you really start to look at it, there are a group of products within your house that are microprocessor intensive, right? And those are generally around your networking, your control systems, your communication systems, all your audio video gear, all of your security. Those are all microprocessor intensive. Now lighting and lighting control. I mean, now lighting is moving towards having a microprocessor on every bulb, which is, it's kind of a cool thing. It's a subject of a different podcast at some point. So you take all of those and you say, I'm going to have those power conditioned. So because microprocessors function best with constant voltage, and they do not do well if there are huge voltage or current swings. So I take that group, I put them on a separate panel in my house, and I go, okay, I am hooking up a power conditioner to that panel. I'm going to have some battery backup for that power conditioner because I am also, on the other side of it, going to have a generator. And that generator is going to take care of huge motors, refrigeration, air conditioning, heating, because those are not microprocessor intensive and can deal with voltage fluctuation. And those are things you sure don't want to lose in a power outage. And unfortunately, because of their power draws, it is hard to get enough batteries to back them up for a long period of time. So now we have a system that's, okay, I've got batteries and power conditioning for my ultra critical loads. I have a generator for my big motors, big draws. So now I have a pretty balanced system. And should the generator run out of fuel, I still have many hours or days of backup for my supercritical loads. And then if you wanted to take the next level up, you could then take solar panels, hook it up to a device like a RoseWater, and have that continue to charge the battery. So your runtime should, if you get a really catastrophic failure, your runtime would be increased because the batteries will keep being charged during the day by the solar panels. And that becomes the ideal situation. It really allows you to downsize your generator a bit, allows you to protect the supercritical loads from your generator and the utility. And it is very typical for a RoseWater product to be put in installation like that. So in my mind, that is the ideal setup.
I like it. I think that was a really, really well-worded explanation and well explained, that's for sure. And so Joe, we've covered a lot of ground here, talked about a lot of different options and provided a lot of positives and negatives to various options and various things that are out there on the marketplace. If you were to put a bow on this episode, how would you just describe the thought process that people should go through and maybe some of the different factors they should think through as they consider the power options for their home? Just give us kind of some final thoughts, a conclusion statement, if you will, to maybe wrap up and tie a bow on this episode.
I think it is, first, extremely important that understanding your priorities. Let's talk about what are priorities. Your supercritical loads. Your power conditioning power conditioned loads not only help you during power outages, they help your day-to-day living. So under those supercritical loads, you are protecting every microprocessor in your house. What does that mean? A good salesperson or consultant will help you determine how big a load those particular items are, and then you would take a device, preferably a RoseWater, because I'm so objective, and use the power conditioning of a RoseWater to back up those devices and protect them. And then sit down and you go, okay, here are the rest of my loads. Now you have to be careful because you immediately want to go to whole house. And you can, but it is not necessarily the right thing to do, because the bigger the generator, where are you going to get the fuel? And what are you protecting against? Are you protecting against an outage that is a few hours, which is 90% of the outages, or are you really looking to protect for a major disaster? In a hurricane here, we can go 7 or 8 days. You just found out that you too can go 7 or 8 days.
As it turns out, yeah.
And it's a drag. And if you have a propane tank powering your generator, you aren't getting deliveries during those 7 or 8 days. So when it's out, you're done. And so you have to engineer, okay, this is what I'm going to protect. And in a once a century event, I'm done. There's nothing I can do about that, except that the power conditioning will continue to protect your house. And then if you want to use renewables, use them intelligently. And it is all about, the real key is having somebody who will understand your objectives and will speak with you in an honest fashion. Because as I say, for, I guess, obvious reasons, but people always start out, I want to do my whole house forever. Well, okay. But that's just not going to be in the realm of possibility for you. That's and they have a house that's 25,000 square feet, so they want to do that for you. So it really is intelligent engineering and having somebody who truly understands each of those options.
Absolutely. And that's why I enjoy these podcasts so much, because I think it's about arming people with the right information, having them ask the right questions and consider the right things when it comes to these important conversations. Because like you mentioned, we here in Texas thought we were impervious to the cold, and we found out that we were not. And so it's good to ask those questions. It's good to have the right information when you go into these types of scenarios, so that you don't make mistakes and you know what you're getting yourself into.
Yes, and you not only get value for your money, you really end up going, I purchased something that makes sense, and look, it's working. That's really the big deal, because people get really angry when they purchase something and it doesn't do what they expect, and I don't blame them.
It's a great point. And it's why it's so essential to always catch every episode of The Next Generation of Energy, so that you know what to expect, you know the right questions to ask, and you get expertise from guys like Joe Piccirilli. So Joe, thank you so much for joining me here for another episode of the show. It's always a blast getting a chance to talk to you and get to have these conversations. Thank you once again.
Oh, it was absolutely my pleasure, and you know how much I enjoy doing these things, so thank you for being a wonderful host.
Well, thank you as always for joining me. And audience, thank you for joining us for this episode as well. Hopefully we gave you a lot to chew on, a lot of things to think about, a lot of good questions to ask, and a lot of good perspective when it comes to these various options out there in the marketplace, so that you can arm yourself with the right kind of information and knowledge moving forward. We appreciate you joining us today very, very much, everyone out there. Stay tuned for more episodes of the podcast. We'll be back soon with more. Of course, you can go back and listen to previous episodes in the meantime as well. But for my guest today, Joe Piccirilli, I've been your host, Tyler Kern. Thanks for joining us.